physics-13.1g-describe with graphical illustrations the changes in displacement, velocity, and acceleration during simple harmonic motion. Question 1. Recall the three graphs for simple harmonic motion and use them to describe the changes in x, v, and a. So the three graphs are as follows. The top one is xt graph with displacement x on the y-axis and with tan t on the x-axis. And the line on the graph tells us that it's a s.h.m function. And in the middle, here is the vt graph with velocity v on the y-axis. And it's a cos.h.m function. We can actually get the vt graph from the xt graph. That's because vt function is just the derivative of xt function. Here, xt function is a s.h.m function, and the derivative of s.h.m function is cos.h.m function. So the vt function we have here is a cos.h.m function. Now let's look at the graph on the bottom. It's a at graph with acceleration a on y-axis. As we can see, it's a negative s.h.m function. It looks like just the line on the xt graph upside down. That's because if you remember, a is equal to negative kx in a simple harmonic motion. And we can also deduce at graph from the vt graph, because at function is actually the derivative of vt function. And now with these graphs, it becomes so easy and convenient to describe the changes in xt, v, and a. For example, during the first quarter of a period, x is increasing from 0 to its maximum, and v is decreasing from its maximum to 0. Now, can you tell me how is a changing during this time interval? It seems that a is decreasing as the line in this section is downward. But what we should note is that x, v, and a are all weight quantities. So the magnitudes of them are determined by their absolute values only. No need to consider their signs. And what the signs of their values represent are just their directions. For example, maybe negative means they are downward, and positive means they are upward. So now you know, during the first quarter period, a is actually increasing, and the value is negative, which means it's in downward direction. So now you know how to describe x with the xt graph, and how to describe v with the vt graph, and describe a with the at graph. But you should also learn to deduce v and a from just one xt graph, because xt graph is the graph we see most frequently. And we've talked about the derivative of xt function is vt function. So the gradient of the tangent to the line of xt graph is v. For example, at this point of time, the tangent to the line is a horizontal line whose gradient is 0. So at this point, v is equal to 0, which is consistent with the value on the vt graph. And what we should know about the gradient of the tangent is that the steeper the tangent is, the greater the gradient is. And the downward sloping tangent means the gradient is positive, and the downward sloping tangent means the gradient is negative. So with these knowledges, you can get both magnitude and direction of v from the xt graph. And deducing a from xt graph is much easier. We know that a is equal to negative kx, where k is a constant whose value is positive. So the magnitude of a is proportional to that of x, but the direction of a is opposite to that of x.